Hello and welcome to Applications to Trigonometry project. Today we're going to be answering the last question in this project, question 10. So the question states, a triangular playground has borders of 52 feet, 70 feet, and 64 feet. To the nearest degree, what is the measure of the largest interior angle of the triangular pyramid? What is the area of the playground? So it's asking us two questions. It's asking us what is the measure of the largest interior angle, uh, right here, and what is the area? Okay, so it doesn't matter what you do first, since we have our three side lengths given and we're asked to find the measure of the angles inside. We're gonna know that we're gonna have to use the law of cosines. And in order to find the area when given three side lengths, you can use something called the Heron's formula. All right, Heron's formula. Uh, okay, formula. All right, Heron's formula is that A, which is area, the area is equal to the square root of uh, S times S minus A times S minus B times S minus C. S is the semi-perimeter, so S is equal to the perimeter over 2. And in order to calculate the perimeter of a triangle, you just have to add up all three side lengths. So we have 52 plus 70 plus 64. So we know that our perimeter is 186, and then we put that over 2. So if S is equal to 93, okay? So now we can plug it in now we can plug this in to Heron's formula. Uh, so we're gonna have A, the area, is equal to the square root. Let's make that a little bit better. Square root of 93 times A, B, and C are basically the three side lengths. So here, let's label it out just for you guys to understand it a little bit better. It doesn't matter what you label it, but A, B, and C. And we're going to put A, like opposite to A, is going to be 52. B is going to be 70. And then C is going to be 64. So S minus A. So 93 minus 52, that's going to be 41, times S minus B, 93 minus 70, that's going to be 23. And then S minus C, which is 93 minus 64, that's 29. All right. And with this equation, now we can find what A is equal to. So all we have to do is plug this in a calculator. We'll have a TI-84. So we're going to do 93 times 41 times 23 times 29 and the square root of all of them. We have A, let's put roughly equal to. A is roughly equal to 1,594.8. And then we have to put our units squared. So it's going to be feet squared. So this is our answer for the second part of this question. So right here, we answered that. So now we have to find the measure of the largest interior angle. So using the law of cosines, we can find, well, first we have to find the angle measures of 2 out of 3 so we can find the third one. So, whoops. All right. So let's see. We're gonna draw our triangle. Let's make this into a different color. Let's do a little divide too while we're at it. Let's make this a more purple color. Okay, so we're gonna label our triangle like we previously did. We're gonna have A, B, and C. Let's make that C a little bit better. All right. We're gonna have 52, 70, and 64. And 64 feet. Then first we're gonna find the measure of angle A. We're gonna have that as our x variable. So we're gonna do uh, the side opposite to 52. We're gonna basically do 52 squared is equal to 64 squared plus 70 squared minus 2 times 64 times 70 times the cosine of A, which is x. Okay, and then we can simplify this equation even more. We know what 52 squared is. 52 squared is 2,704, and then 64 squared plus 70 uh, plus 70 squared is equal to 8,996 minus, so negative 2 times 64 times 70 is minus 8,960 times the cosine of x. We're going to simplify this equation further. We're going to minus 8,996 from both sides. And then on the left side of the equation, we're going to be left with a negative number, which is going to be negative 6,292 is equal to negative 8,960 times the cosine of x. Then we're going to divide each side by negative 8,960 in order to leave the cosine of x by itself. Then on the left side of the equation, we're going to be left with, oh, let's add another 9 there. Oh, no, that's not, you don't add another 9. 1,960. All right. 8,960. We're going to be left with 0.7, roughly 0.7 is roughly equal to the cosine of x. And in order to leave the x by itself, we are going to do the inverse cosine. So we're going to do inverse cosine of zero point 0.7 is roughly equal to x. And then plug that in the equation and you get that x, or better yet, better than x, we get measure of angle A, because that's our x value, it's the same thing. So measure of angle A is roughly equal to the inverse cosine of 0.7 is 45 degrees. Real answer would be roughly 45.4, but remember the question, it asks to the nearest degree here, to the nearest degree. So the nearest degree would be 45 degrees. Okay, so we're going to solve for the angle of measure, the measure of angle B. This is going to be our new x variable. Here we can erase this, and then add our black marker here. Let's make that a little thicker. All right, put that at 4. Okay. As what? 45. All right. So measure of angle B. We look at the side opposite to it. Here we can just actually we can erase all of this. So select. Can we do like that? Yeah. And then we're going to cut. All right. Then it's gonna make us do all of that. Man, oh man. All right. Here we go. If you need to see the work, you can go back. We need the space here, man. We need the space. Okay. So we're gonna do this in a different color. We're gonna do this in a more orange color. Okay. So let's find measure of angle B, which is gonna be our x value. We're gonna look at the side opposite to it, which is 70. We're gonna do 70 squared is equal to 64 squared plus 52 squared minus 2 times 64 times 52 times the cosine of x. All right, simplify this equation even more. We do 70 squared, which is equal to 4,900, is equal to 64 squared plus 52 squared. That is equal to 6,800. Negative 2 times 64 times 52 is equal to negative 6,000. Let's make that a little bit better. 6,656 times the cosine of x. And you can't minus these two values together because this second part is being multiplied by the cosine of x, or is multiplying cosine of x. So you can't just do 6,800 minus this and then just be left with cosine of x. It's not how it works, sadly. Nothing in math is simple. So you minus 6,800 on both sides. And then you're left on the left-hand side with negative 1,900. And that is equal to negative 6,656 times the cosine of x. You're going to divide negative 6,656 on each side in order to be left with merely the cosine of x. Divided by a negative 6,656, that is equal to, so we're going to have the cosine of x, because remember these two cancel out. Cosine of x is, well, okay, cosine of x is roughly equal to 0.2855. And again, in order to leave the x value by itself, you do the inverse of cosine. So we're going to have the inverse cosine of 0.2855 is roughly equal to x. And then remember, x is the measure of angle B. So when we get to the last step, we can just switch the x to measure of angle B. It's not necessary, but it does help you out. So measure of angle B is roughly equal to the inverse cosine of our number, which is roughly equal to 73 degrees. Okay, so we got that, and I'm going to show you guys a rather simple way to find the third one. Most of you guys probably already know this, but for some who don't know, okay, same color, all right, 73, let's make that a little bit better, 73 degrees. Okay, so let's do this simple math real quick. We know that the sum of all angles in a triangle has to equal to 180. So we have to know that the measure of angle A plus the measure of angle B plus the measure of angle C has to equal to 180. We already know the measure of angles A and B, so we can easily find C. So we know that 45 plus 70, well, that's a 3, not a 7, plus 73 plus x, which is the measure of angle C, excuse me, is equal to 180. And then with this, we can easily find that x is equal to, let's do 45 plus 73, and then 180 minus that answer is 62 degrees. So we know that the measure of angle C is equal to 62 degrees. What in the world is that? Okay, all right, 62. And then if we go back up to our question, it asks us to the nearest degree, what is the measure of the largest interior angle? Largest right here. So we go back to our measures and we look at the largest angle, and then we know that that is the measure of angle B, which is 73 degrees. So we're going to put it next to here, 70, or we're going to put measure of angle B is roughly equal to 73 degrees, highlighted in green or boxed in green, so we know that's our answer. And well, that's it. That's how you use Heron's formula, and that's how you use the law of cosines in order to solve a two-step problem, word problem. Hope you guys enjoyed the series, and I hope to see you guys again soon.